If it goes through the keyhole, it will hit us April 13th, 2036. The chances of this now, our data tell us, is several in a million. But there are people who buy lottery tickets with worse odds than that, expecting to win. It'll hit Santa Monica, it'll explode, 50 feet tsunami, 5-story tall, that will come to the west coast of North America and basically wipe it clean.
Imagine cruising through a vast space minefield. That's pretty much what Earth is doing every day. Neil deGrasse Tyson, a big shot in the world of astrophysics, gets the heebie-jeebies when it comes to asteroids. And honestly, it's easy to see why. These aren't just the stuff of epic sci-fi movies, they're real, and they're out there zipping around in space. We're talking about chunks of rock and metal, leftovers from the solar system's early days, some of which could be on a collision course with our planet. But what exactly are we dealing with here? Well, it's a mix. You've got asteroids that are no bigger than pebbles, and then you've got the big kahunas, ones that are the size of mountains or even larger, and they're all just floating around in space, following their paths around the sun. The thing is, their orbits can be a bit like a pinball machine, unpredictable and at times downright dangerous for Earth. These space rocks are fascinating in a way. They're like time capsules holding secrets from billions of years ago when our solar system was just taking shape. But they can also be a bit scary. After all, a big enough asteroid smacking into Earth could be bad news. We're talking about potential global consequences, from tsunamis and earthquakes to climate changes that could really shake up life as we know it. Have you ever thought about the times Earth has played cosmic dodgeball with asteroids? Let's talk about some of Earth's most dramatic run-ins with these space rocks, starting with a biggie, the Chicxulub impactor. Picture this. About 66 million years ago, a giant asteroid, about 10 kilometers across, comes hurtling towards Earth. It crashes into what's now the Yucatan Peninsula in Mexico, and boom! It unleashes energy like billions of atomic bombs, creating a crater 150 kilometers wide and 20 kilometers deep. The aftermath? A global climate shakeup, and about 75% of Earth's species, including the dinosaurs, say their final goodbyes. Fast forward to a more recent event, the Tunguska explosion in 1908. This wasn't a direct hit, but it was still a showstopper. An asteroid or comet fragment, maybe about 50 to 60 meters wide, bursts in the sky over Siberia. The blast, with the power of 10 to 15 megatons of TNT, flattens a whopping 80 million trees across 2,150 square kilometers. That's an area bigger than some major cities. And get this, there was no crater found. Scientists think the object just blew up mid-air, about 5 to 10 kilometers above the ground. The Tunguska event is a bit of a cosmic wake-up call. It showed us that these space rocks can be pretty sneaky and unpredictable. It wasn't like we had a heads up to brace ourselves. This unpredictability is why keeping an eye on the sky for asteroids is super important. You never know when the next big one might make an unwelcome visit. Let's get into the fascinating world of asteroid tracking, where scientists become cosmic detectives. Imagine trying to keep tabs on space rocks cruising through our solar system, some of which might get a bit too cozy with planet Earth. This task is a blend of astronomy, physics, and some serious sleuthing. So how do you track a hunk of rock zipping through space? First, you gotta spot it. Scientists use beefy telescopes, both chilling on Earth and orbiting in space, to catch a glimpse of these celestial wanderers. Once they've got an asteroid in their sights, it's all about measuring where it is, how bright it is, and how it's moving compared to the stars. This info helps work out the asteroid's orbit, speed, size, and where it might be heading. The process, called astrometry, is like celestial cartography, mapping out the positions and paths of these space rocks. But spotting an asteroid is just the start. Predicting where it's going to be in the future is a whole other ball game. It involves some hefty math and computer simulations. Scientists juggle the laws of how celestial bodies move and toss in factors like the pull of gravity from other planets, the asteroid's own twirl and shape, and even how the sun's heat gives it a gentle nudge, something known as the Yarkovsky effect. One of the big players in this game is NASA's Near-Earth Object Observations program. These folks are on a mission to find and track at least 90% of the near-Earth objects out there that are 140 meters or more in diameter, the kind of rocks that could really ruin our day if they hit us. Then there's the European Space Agency's Hera mission, gearing up for a 2024 launch. Hera's going to take a close look at the Didymos asteroid system and its little buddy Dimorphos. It's like a follow-up gig to NASA's DART mission, which is testing out if we can actually shove an asteroid off its course by ramming a spacecraft into it. But here's the kicker. Tracking asteroids isn't a walk in the park. There are loads of them we haven't even found yet, and some are tough to track because they're small, dark, or zipping around super fast. Plus, space is huge, and asteroids are like needles in a cosmic haystack. Have you ever thought about how Earth has had some really close calls with asteroids? These near misses are like nature's warning shots, reminding us that we're just a tiny part of a vast, dynamic universe. Take the Chelyabinsk event in 2013, for example. This was a real eye-opener. A relatively small asteroid, just about 20 meters across, came out of nowhere and exploded over Chelyabinsk, Russia. The blast was massive, releasing energy around 30 times greater than the Hiroshima bomb. It wasn't just a light show. The shockwave broke windows and even damaged buildings, injuring over 1,000 people. It was like a scene from a movie, but very real and pretty scary. This event showed us that even a small space rock can pack a massive punch, but Chelyabinsk isn't the only time Earth had a narrow escape. Let's rewind to 1908, the Tunguska event. An asteroid or comet fragment blew up over Siberia, flattening about 80 million trees over a massive area. It's like Mother Nature showing off her power. More recently, in 2021, we had asteroid 2001 FO32, about 900 meters in size, cruised by Earth. It was 2 million kilometers away, which sounds like a lot, but in space terms it's pretty close. What's tricky about these cosmic wanderers is that they can be hard to spot. They're like stealthy space ninjas, small, dark, or sometimes hidden by the sun's glare. This makes predicting their paths quite challenging. Scientists are constantly on the lookout for these elusive space rocks. Projects like Pan-STARRS in Hawaii and the Catalina Sky Survey in Arizona are like our cosmic watchtowers. They're scanning the skies, trying to spot any potential threats. And then there's NASA's NEOWISE mission, using an infrared space telescope to find asteroids that might be too dark for regular telescopes to see. But here's the catch. Our tech isn't perfect. We're pretty good at spotting the big asteroids, but the smaller ones, like the one that hit Chelyabinsk, can slip under the radar. With millions of these small near-Earth asteroids zooming around, it's a bit like finding a needle in a haystack. Now let's wade into the mysterious world of asteroid impact conspiracy theories. It's a place where wild speculation meets a sprinkle of imagination, and sometimes it can clash pretty hard with scientific facts. These theories have a bit of everything, from hush-hush government secrets to alien shenanigans. One popular tale you might hear whispers about is that governments or big space agencies, like NASA, are sitting on a goldmine of secret info. They supposedly know about a doomsday asteroid on a crash course with Earth, but are keeping it on the down low to prevent mass panic. It's a theory that could be straight out of a thriller movie, but when you shine the light of science on it, it kind of falls apart. Here's the thing. Keeping an eye on asteroids is a huge international effort. We're talking about a network of observatories and agencies all around the globe, constantly watching the skies. Keeping a secret of this magnitude under wraps, highly unlikely. Then there's this other out there idea. Some asteroids zipping through space are actually alien spacecraft or probes under the watchful eye of extraterrestrial beings. It's a theory often fueled by the weird shapes or paths some asteroids take. But in the world of astronomy, these oddities usually have more down-to-earth explanations like natural erosion, cosmic smash-ups, or just the simple tug of gravity. And let's not forget about the theories that suggest some shadowy groups or governments are cooking up secret plans to either weaponize asteroids or use them for some sort of space-age power play. While the idea of redirecting asteroids is a genuine scientific pursuit, the notion of using them as cosmic weapons is more sci-fi than science fact. It's important to remember that these conspiracy theories, as entertaining as they might be, can sometimes cast a shadow over the real, critical work happening in asteroid tracking and planetary defense. This field is all about open collaboration and sharing knowledge. Scientists from around the world team up, share their findings in peer-reviewed journals, and keep databases like the Minor Planet Center up to date with the latest asteroid orbits. Plus, there's Asteroid Day, an annual event where space experts gather to spread the word about asteroids. It's all about education and transparency, showing just how open the field of asteroid research really is. So while it's fun to entertain these space rock conspiracies, the truth is often more grounded and collaborative. It's a global effort where scientists are the real heroes, working hard to keep our planet safe from any unwelcome cosmic visitors. What if I told you that we're actually cooking up plans to save Earth from a Hollywood-style asteroid catastrophe? It's true. Scientists and engineers are working on some pretty cool strategies to deflect a rogue asteroid heading our way. This isn't sci-fi anymore, it's real science in action. Let's start with the big guns, nuclear deflection. Now, this isn't about blowing an asteroid to smithereens like in the movies. Instead, it's about setting off a nuclear explosion near the asteroid to gently push it onto a different path. It's like giving the asteroid a little nudge away from Earth. This could be a game changer for dealing with big asteroids, but it's also a bit controversial. There's the whole unpredictability of nuclear blasts in space and the risk of breaking the asteroid into smaller, yet still dangerous pieces. Then there's this super cool idea called kinetic impactors. Think of it as playing interstellar billiards. We send a spacecraft to smash into the asteroid at high speed, which changes its course. NASA's got this project called DART, the Double Asteroid Redirection Test, where they're actually going to try this out. They're planning to whack a spacecraft into an asteroid's little moon to see if they can change its orbit. It's like a real-life experiment to test out our planetary defense skills. Another nifty idea is the gravity tractor. Picture a spacecraft just hanging out near an asteroid for a long time, using its own gravity to slowly but surely pull the asteroid into a safer orbit. It's a slow and steady approach and less likely to break the asteroid apart. But it's a bit like watching paint dry, it takes a long time. It must have been an exciting time to witness the discoveries of Venus when they were made, and what they meant to scientists at the time. The first images, the first data transmissions, all were groundbreaking at that moment. What we learned from it had scientists confused as to what we had expected when the landing was made. Before we get into the discoveries made during the Venus landing, let's talk about how it was all achieved. Now let's get into the Soviet Union's Venera program, which is like a grand saga of space exploration. This story starts in the early 1960s and goes on for over 2 decades. It's a journey of courage, innovation, and a bit of mystery, much like the quests of ancient explorers, but this time it's in the cosmic ocean. Imagine it's 1961 and here's Venera 1, ready to make history as the first spacecraft to fly by Venus. It's like launching a message in a bottle into the vastness of space, hoping to uncover the secrets of Venus. Venera 1 was packed with cool gadgets, a magnetometer, cosmic ray detectors, stuff that would make any tech enthusiast's heart race. But here's where the plot thickens. Just a week after launch, we lost contact. It's like the spacecraft just vanished into the cosmic void, probably because of a power failure. It was a setback, but think about it. This was humanity's first shot at reaching another planet. Fast forward to 1965, and we have the twin adventurers, Venera 2 and 3, aiming not just to fly by Venus, but to touch its surface, a feat straight out of science fiction. Venera 2 got tantalizingly close, but then silence. It probably got overwhelmed by Venus's hot temper, metaphorically speaking. Then there's Venera 3. Now this one's a dramatic twist. It actually crash-landed on Venus. It was like touching an alien world, but without a word back. No data, no whispers from another world, just a silent landing. It's kind of eerie when you think about it. The first earthly object to touch another planet, and it's just sitting there silent in the Venusian landscape. Let me tell you about the Venera 4 mission in 1967, which was an absolute game-changer in our quest to unravel the secrets of Venus. Launched in June, this intrepid explorer dived into Venus's atmosphere by October, becoming the first mission ever to send us real-time data from another planet's atmosphere. But here's where the drama intensifies. Venera 4, designed to withstand pressures we thought were tough enough, was in for a surprise. Venus's atmosphere was way more crushing than we'd ever imagined. At about 27 kilometers above the surface, our brave little probe couldn't take it anymore. It was a valiant effort, but Venus proved too much for it. Now, riding on the wave of excitement from Venera 4, in come Venera 5 and 6 in 1969. These siblings of space were on a mission to delve even deeper into the enigmatic atmosphere of Venus. They plunged into the Venusian atmosphere, beaming back more data, building on the story that Venera 4 had started. It was like putting together pieces of an interstellar puzzle. But just like Venera 4, they couldn't touch the surface. The extreme conditions of Venus claimed these probes too before they could make a landing. The findings from these missions, especially Venera 4, were monumental. They didn't just give us a glimpse into Venus's atmospheric secrets, they set the stage for future missions. It was like we had just opened a new chapter in space exploration, learning not just about Venus, but also about designing spacecraft capable of withstanding such extreme environments. As the missions evolved, they turned into a real cosmic saga, unveiling secrets of our mysterious neighbor Venus. Let me take you through this amazing journey. In 1975, Venera 9 and 10 were launched, packed with the latest tech to land on Venus. What happened next was nothing short of historic. Venera 9 lands and bam! It sends back the first ever images from Venus's surface. We're talking groundbreaking stuff here. The first time we Earthlings got to see what Venus looks like up close, a rocky landscape that was just mind-blowing. And then, Venera 10 follows up, landing successfully and sending back more pictures. This was a big deal because now we had more than just a glimpse. We had actual clear views of an alien world surface. But the adventure didn't stop there. In 1978, here come Venera 11 and 12 with a mission to dive deeper into the mysteries of Venus's atmosphere and surface. They were like cosmic detectives armed with all sorts of instruments, spectrometers, gas analyzers, you name it. Sure, they ran into some hiccups with their cameras, but the data they sent back, pure gold. They gave us a peek into the chemical makeup and the dynamic nature of Venus's atmosphere. Now fast forward to 1981, and get ready for this, Venera 13 and 14. These missions were out of this world, literally. Venera 13 does something extraordinary. It sends back the first color images of Venus's surface. Imagine that, seeing the surface of another planet in color for the first time. And right on its heels, Venera 14 also sends color images and does all these cool experiments, adding even more to our understanding of Venus. Getting into the Vega program, which was like the grand finale of the Soviet Union's exploration of Venus. In 1984, something truly extraordinary happened with the launch of Vega 1 and Vega 2. These missions were space exploration at its most daring and inventive. They weren't just going to Venus, they had a double agenda. After swinging by Venus, they were set to rendezvous with none other than Halley's Comet. It's like hitting two cosmic birds with one stone. Now here's where it gets really interesting. When Vega 1 and 2 got to Venus, they didn't just orbit or land, they deployed balloons. Imagine that, balloons floating in the alien atmosphere of Venus like something out of a Jules Verne novel. These balloons weren't your average party balloons. They were sophisticated, floating around, collecting all sorts of data on Venus's weather and atmospheric conditions. It was a first in interplanetary exploration, and the kind of stuff that gets you thinking, what else is possible? But the journey didn't end at Venus. After their Venusian escapade, both Vega spacecraft continued on their cosmic path to meet up with Halley's Comet. This was a big deal because comets are like the time capsules of the solar system, and Halley's Comet is the most famous of them all. The Vega missions gave us a chance to peek into the very building blocks of our solar system. Sadly, though, by the late 1980s, things began to change. The Soviet Union started shifting its focus away from Venus, marking the end of an era in space exploration. But let's not forget the impact of the Venera and Vega programs. They were like the trailblazers of space exploration. Now let's discuss some of the incredible discoveries that concern scientists from Russia's Venus landings through the Venera program. These missions were like interplanetary detectives, uncovering secrets of Venus that blew our minds. First off, the atmosphere of Venus, it's almost entirely carbon dioxide. We're talking a whopping 96–97%. This was a huge find. It's like Venus was showing us what a runaway greenhouse effect looks like up close. And the pressure, oh boy, it's like nothing we have on Earth, about 92 times what you'd feel at sea level here. Can you imagine that kind of squeeze? It's like being deep underwater, but on a whole planet. Then there's the heat. Venus is scorching hot, averaging around 465 degrees Celsius. That's hot enough to melt lead. It paints a picture of a world that's not just hostile to life as we know it, but also a brutal challenge for any spacecraft brave enough to land there. And the landscape. It's like something out of a sci-fi movie. The Venera probe sent back images and soil data that showed a world shaped by volcanic forces. We're talking about a terrain covered in basalt-like rocks and signs of extensive lava flows. It's a volcanic wonderland that completely changed our view of Venus's geological past. Now get this, Venus's clouds are made of sulfuric acid. Talk about harsh weather. This revelation wasn't just about how extreme Venus is, it also raised big questions about how planets evolve and what kind of tech we need to explore such hostile environments. But here's something really out there. The Venera missions detected lightning in Venus's atmosphere. Yes, lightning. This suggests that Venus has some pretty dynamic and complex weather patterns, despite its slow surface winds and dense cloud cover. It's like Venus is keeping a few secrets up its sleeve, challenging what we think we know about planetary weather. Now lastly, let's get into some of the mind-bending stuff we learned about Venus from the Venera missions, particularly its rotation and magnetic field, and what this all means for future missions. Venus, this enigmatic neighbor of ours, has some peculiar tricks up its sleeve. Firstly, Venus's rotation is a real cosmic oddity. It spins backward compared to most planets in our solar system. That's like watching a ballet dancer suddenly pirouetting in the opposite direction. And talk about taking its sweet time, a day on Venus is longer than its year. Imagine having a birthday every day, that's Venus for you. This slow retrograde spin is more than just an interesting fact. It's crucial for understanding the planet's atmospheric dynamics and why it doesn't have much of a magnetic field. Speaking of magnetic fields, Venus's is incredibly weak. It's like having a faint shield against the solar wind, the stream of charged particles coming from the sun. This weak magnetic field lets the solar wind strip away particles from Venus's upper atmosphere, which is a big deal for understanding how planets lose their atmospheres over time. Now, these findings aren't just cool bits of trivia. They have serious implications for future missions to Venus. The extreme conditions there, the intense heat, crushing pressure, and the corrosive atmosphere are like the ultimate test for spacecraft engineering. It's like designing a car that can drive through a volcano. The data we've got from Venus also makes us wonder about how planets evolve. Venus is like Earth's twisted sister, showing us what happens when the greenhouse effect goes into overdrive. This comparison gives us valuable insights into our own planet's climate and geological history. And here's where it gets really intriguing: the search for life. Sure, Venus's surface seems like the last place you'd find life as we know it, but those discoveries of complex atmospheric chemistry and lightning, they crack open the door to the possibility of life in Venus's upper atmosphere. It's like finding out there might be a hidden oasis in the middle of a cosmic desert. The more we learn about Venus, the more it surprises us, fueling our curiosity and our drive to explore the unknown.